Hello everyone, welcome to undergraduate tutorials. Today on undergraduate tutorials we are going to look at physics 101 and the topic is still dimensional analysis. Remember that we have looked at the first part of dimensional analysis where we considered the basic terms associated with dimensional analysis, and then we also looked at how we can obtain the dimensions and units of derived quantities. Today on undergraduate tutorial we are going to look at another aspect of dimensional analysis, and that is finding constants that we make a dimension correct. This is still physics 101 in undergraduate tutorial. Remember, the course code doesn't matter because in your school they may use a different course code. The most important thing is that the course outline are the same. Alright, let's begin today's journey on dimensional analysis. Remember, we said there are 4 aspects of dimensional analysis and we have been able to look at one aspect. Today we are looking at the second aspect. It is important that you watch the previous video where we treated how you can obtain the units and dimensions of derived quantities. And then it's also important that you always leave a comment and also ask questions where you are confused. Definitely we'll go through your comment and then reply you appropriately, whether on YouTube or on our WhatsApp platform. Thank you. Now today our business is to look at how we can find constants that will make a dimension correct. Now if we have the dimension of a given quantity, let's say we have something like this, and they say this represents the dimension of a particular quantity. We know we cannot actually state the quantity that has this dimension because we have unknown constants. A, B, and C are all unknown. We're supposed to know the powers or the exponent of M, L, and T in order to ascertain which quantity has this particular dimension. So our business is how do we find these constants that will make a dimension correct. That's our business today. And for us to do that, there are steps that we need to take. There are steps that we need to take. We always like to break everything down to steps so that people can easily understand them. So let's look at the steps that we need to take in order to find constants that will make a dimension correct. So what are the steps? So step number 1, take note of the given dimension and the quantity it represents. So that's the first step. The second step is write the correct dimension of the quantity. Write the correct dimension of the quantity. Then the third step, equate the powers of similar terms. Equate the powers of similar terms to find the unknown constants. So these 3 steps will be enough for us to carry out our calculations or for us to evaluate expressions like this when we have a dimension that the constants in the dimensions are unknown. That's the powers in the dimensions are unknown. So let's follow these steps and solve 1 or 2 problems as far as this aspect of dimensional analysis is concerned. So let's take example 1. Example 1. If the dimension of energy is m to power x, l to power y, t to power z, find the values of x, y, and z. So if the dimension of energy is that's the dimension of energy, we are asked to find the values of x, y, and z that will make this to be the dimension of energy. So we begin. Let's solve this. Following these steps, take note of the given dimension and the quantity it represents. Let's take note of this dimension and t to the power z. And we are told that it represents what? Energy. Okay? We now say write the correct dimension of the quantity. Alright, we still pull this down. What's the correct dimension of energy? Energy is mL squared T raised to the power minus 2. That's energy. Remember, energy has the same dimension as work done. Yes, you remember that. And we know that work done is force times distance. The dimension of force is mass times length per times square. That's mass times acceleration. That's force. Then distance has the same dimension as what? Length. So when you multiply these two terms, you are going to have this. So work done and energy are the same. Even if you use maybe potential energy is mass times acceleration times what? Height. So you still say mass, acceleration is L per time squared, then height is still length. So when you multiply this, you arrive at this. That's how we obtain the dimension of energy. Okay? So we have done the first two steps. Now let's look at the third step. Equate the powers of similar terms to find your known constant. So this term is similar to this. So what's the power here? X. What's the power of that term on the other side? 1. So S is equal to 1. Then Y. This term and this term are the same. They are similar. So what's the power here? Y. What's the power here? 2. Then for T, the power here is Z and the power here is minus 2. So if this dimension is going to be the dimension of energy, definitely X will be 1, Y will be 2, and Z will be what? Minus 2. Z will be minus 2. Alright. We need to take another question quickly before we go on a short break. So let's take another question quickly without taking much time. Example 2 now. Example 2. Let's look at this. Example 2. Example 2. Okay. Given that the dimension of density is m to the power x, l to x plus y, and t to minus 3z. Find the values of x, y, and z. Okay? Given that the dimension of density is that, find the values of x, y, and z. Okay? Now, still following our steps, take note of the given dimension. So the given dimension is mass to power x, L to power x plus y, and t to power minus 3z. It's equivalent to the beautiful quantity we call density. Density is a very beautiful quantity. You know about density. Now, they say write the correct dimension of the quantity. Write the correct dimension of the quantity. We know that the dimension of density is length, is mass per length cube. So we have that L to x plus y, t to minus 3z is this. You know, density rho, remember rho, density is mass over volume. Dimension of mass is still m. Volume, the dimension of volume is length what? Cube. That's the dimension of volume is length cube. So by the time you now simplify this to this form, you're going to have this as the dimension of density. Alright, now there is a little thing that we have to do here. If you look at this side, we have the t term, but here there is no t term. So if we actually equate the powers properly, definitely we have to introduce the t term here. And we know that any number raised to power 0, any term raised to power 0 is 1. So we have to, it means since the t term is not here, it means that its power is 0. That's why it's not existing here. So that t raised to power 0 is 1. 1 times the whole of this still gives us this. You see that? So if I have m l minus 3, it's still the same thing as saying m l raised to power minus 3 t raised to power 0. Because t raised to power 0 is 1. 1 times this will return to this. This is very important in case you have a situation where one of the dimensions is missing, then you need to introduce it and give it, assign it a power of 0. Very important. So now, having done that, we need to start our step number 3. Equate the powers of similar terms to find your known constant. So this and this are similar. X will give us what? 1. Now the power of L here is s plus y, and the power there is minus 3. So s plus y is minus 3. We have found x already. X is 1 plus y equals minus 3. So it means that y will be minus 3 minus 1. Y will give us what? Minus 4. Then we can find z. Minus 3z is equal to 0, because the power of t here is minus 3z, the power here is 0. So z becomes 0 over minus 3, and z will give us what? 0. So if this will be the dimension of density, what it means is that s we have a value of 1, and L we have a value, or x we have a value of 1, y we have a value of minus 4, and z we have a value of 0. Alright. So that's what it means to find constants that will make a dimension what? Correct. But remember that we are not going to leave you without giving you some takeaway questions that you need to solve, so that we know whether you have actually, whether you understood what we have done so far as far as this aspect of dimensional analysis is concerned. So just get ready for your takeaway question quickly. We just have to give you just 2 questions that you need to solve, so that we are certain whether actually you know what we have done so far. Alright, let's look at those takeaway questions before we go for a break and return to continue with other aspects of dimensional analysis. So take away questions. Take away questions. Okay, question number 1. Question 1. If n to power a, l to power a plus 2b, then t to power c are the dimension of momentum find the values of a, b, and c. Okay, given that the dimension of pressure, given that the dimension of pressure is m to power x, l to power 2x over y, and then t to power minus 1 over z. Find the values of x, y, and z. Alright, so we need to solve this in order to enhance our knowledge as far as this aspect of dimensional analysis is concerned. We're going to take a short break, and when we return, we're going to look at the third aspect of dimensional analysis, which is how do we find mathematical relationship between quantities using the principle of dimensional analysis. Continue to enjoy our videos. Thank you, and God bless you.